Okay, it's another time again. I would like to take this opportunity to welcome some physical, electrical engineering students and also some online students who are not physical with us into our interesting moments of just learning the contents in Tanzania Online Institute of Technology. This is our online institution. At this time, we don't have physical institution. However, that we are teaching also locally at the Islam Institute of Technology. My name is Olenjolai. It's the first time to meet me. I'm very happy to have you. And I would like to say welcome to Department of Electronics. The module that we are going to discuss today is called Instrumentation and Measurement. And we are still in chapter 1, but we still have 2 lectures before we end chapter 1, titled Introduction to Instrumentation and Measurement. Then this is lecture 4, User Manuals of Electronics Measuring and Testing Instrument. In case you have missed lecture 0, lecture 1, lecture 2, lecture 3, you can access in our official YouTube channel that's called the Tanzania Online Institute of Technology. So these contents are important or very crucial to the beginners, engineers, and technicians in any related field, in any electric and the related fields, related electric fields. So it means that if you're a beginner, you're intermediate, or you're a professional engineer or technician, this is the good environment for you just to learn about the theory of instrumentation and measurement, but also the simulation of instrumentation and measurement. And also you're going to cover the real practicals of performing measurements of different electrical parameters or electrical physical quantities. So these are the contents, some primary level based. Maybe you are professional, maybe you don't have experience, maybe you just passionate with electrical engineer. Well, whether you're a graduate of A-level educations or O-level educations, or you are first year or second year or third year or fourth year in a bachelor degree in electrical engineering or telecommunication engineering or electronics engineering or mechatronics engineering or computer engineering or biomedical equipment engineering or telecommunication engineering, then these contents are very important for you. We are going to make something today. I have some physical students. Let me appreciate them because I always appreciate people. And one question I want to give you today, because you are going to learn about user manual. One of the precautions in my own teaching and engineering user manual is this one. Olenjolai does not know everything about instrumentation and measurement. Olenjolai is a consistently and everlasting student in the field of instrumentation and measurement. But Olenjolai has the responsibility to teach others about what I know concerning about instrumentation and measurement, right? Well, so how are you, electrical engineering students? Yeah. Are you ready for lecture 4? Yes. Okay, read the title for lecture 4. It's called what? Well, so let us do the quick review of what we have discussed in lecture 4, in lecture 3. So the title of lecture 3 is actual that user manual of electronics measuring and testing instrument. and testing instruments. Then the second concept that we say that we have how many parts? 10 main, just we call them 10 common main parts of of user manual. Okay, I say that some of the user manuals are longer and some of the user manual are shorter. Some of the user manual have the 10 main parts, and some of them they have less than 10 main parts, and some of them they have more than 10 main parts, right? So bear that in your mind. So sometimes you can find some of the user manuals which have 50 pages or 60 pages. Okay, so sometimes you don't have enough time to read or to go through print to print. So you should know the important parts that you have to read. And then we say that we mentioned about those 10 parts. The first one is what? Just remind us. The first part is called what? Introduction. And we say that these main parts are arranged systematically from the first to the last, right? So you have to make sure that you maintain the order. The first one is what? Introduction. The second one is what? Safety what? Safety precaution. And then the third one is what? Pardon? Product overview. Then the next part, the fourth part is what? Getting what? Getting started. Getting started. Then the fifth one is what? Operating what? Operating condition what? Instruction. Operating instruction. Then number 6 is what? Calibration. Calibrations and what? And the accuracy. Calibration and the accuracy. Number 7 is what? Maintenance. So maintenance. Maintenance and what? And care. Then we say that in this class we have a number of students who like to be cared. Who like to be what? Cared. So ask your neighbor, do you like to be cared or do you like to care? Ask your neighbor, do you like to be cared or do you like to care? No, number 7 is not maintenance. Yeah, so now you have already lost it. Number 7 is troubleshooting. Is it? Is it troubleshooting? Okay. Then number 8 is what? Maintenance and care. Then the 9th part is called what? Specifications. So you can ask your neighbor, what are your life specifications? Then number 10 is called what? Warranty and support. Then at the end of the lecture 4 or lecture 3, I told you that please ask your neighbor to give you lunch warrant. So give me the feedback. Did your neighbor give you a lunch warrant? No. Why? Why? So we have discussed here about introduction. How many sentences did we learn introduction, right? 2 or 3, just the 2 format, right? The first one, actual, to appreciate who? To appreciate client. Thank you for purchasing our digital multimeter. Thank you. So even yourself, tell your neighbor, even yourself. Say, tell your neighbor, even yourself. Yeah, you have to appreciate your manufacturer. Who is your manufacturer? Not your father and your mother. Your manufacturer is God. So now say, thank you God for creating me. Say that. Good. You honor God. And then God will say, okay, I will give you long life. Then the second one is you have been actually given a please language. It means a polite language. Please read careful. This what manual before what using the instrument. For instance, before using the digital multimeter, before using the AC generator, before using the AC transformer, before using the let's say the signal generator, before using the oscilloscope, before using the spectrum analyzer, before using the clamp digital multimeter. So you have to read this manual careful before using that instrument. And then we discussed about safety precaution. How many safety precautions did we discuss? The first one is what? Pardon? Safety what? Electric safety. The second one? High voltage what? Warning. The third one? Protecting gears. The fourth one? Temperature measure. And the last one? Storage. So ask your neighbor, which one did you like among the 5? Okay, so in case you've missed the details, it was actually a lecture of 90 minutes, means 1 hour and a half. And I have processed it by God's grace. It will actually that you'll have it within just I think that this week or at the beginnings of the next, this week you'll have it. Okay, so let us continue with the third part. What are the names of the third part? Again, say it loudly, say productive overview. Again, say productive overview. Again, say loudly productive overview. Again, say loudly productive overview. Well, so this is very important because it's a part actually giving you the brief description about the instrument. Also, yesterday I brought to you this digital multimeter, which is consists of multiple of measuring, electronics measuring and testing instrument. And this is the sample of the product. Right? Right? Yes. Are we together? And because we are going to use this one, we have it in our lab. We have a number of them, more than 10 digital multimeters. So while I'll be teaching, I will actually give somebody to take a photo in 3-dimensional. Say 3-dimensional. So take a photo of this part, take a photo of these leads, take the photo of this side, and back side, because it's very important. And then share in our subgroup. Who is ready for that? You, madam? Not you. You? No. So Yuma, because Yuma has authority. So take the 3-dimensional photo and then share to your group. So again, say product overview. So this section of the user manual, these sections of the user manual provides overview, a brief overview. A brief overview. Say a brief overview. Say a brief overview. Okay, a brief overview about what? About the measuring in context of instrumentation, measuring about what? Maybe electronics, electronics measuring instrument. So when you talk about overview, it's not a detail. It's not what? A detail. So also it provides what? It provides key components. Key what? Components. Say key components. Say key components. Listen. Can I have it? Are you done? Yeah, listen. When you talk about, you might still taking a photo. Okay, when you talk about product overview, say product overview is just a highlight. Sometimes you can call it a product highlight. It means that it's not a detailed instruction, right? So even yourself, tell your neighbor, hello my neighbor. Tell your neighbor, hello my neighbor. You just have overview. You just have overview knowledge about me. Tell your neighbor, you just have overview knowledge about me. Yaani wewe jirani yako unayekaa naye, yamkini ya kwamba umekutana naye mwaka mmoja uliopita, lakini alishaishi miaka 20. Kwa miaka 20 iliyopita ulikuwa humjui. Lakini you can say that, oh, this is my friend, I know him, I know her. Okay, fine, but you just know the overview. Okay? Are we together, class? Are we together? Yes, so when you think about the instrumentation measurement, just think about real life and the human life. So when you talk about the key components, say key components. What does it mean? For instance, when you buy this digital multimeter, it doesn't come itself. Listen, in its box you'll find that you have a digital multimeter packaged, and sometimes you can find some nylons and whatever just to pack it, just to protect it against the dusties. And then you find these lids also are packed separate. And also you might find that the external battery also is not placed or inserted within the digital multimeter. So when you say it's key components, it means that the product with its parts. So this is the product. Its parts, one of its parts is the battery. Another part is these test leads, right? And also another part is what you can find the manual. So this is actual will give you the overview. The overview, the brief description about the product, but also the key component. What do you expect to find in its box? Are we together? Are we together? Okay. So let us try to check some parts of the product overview. So the first thing we say that we have package contents. So in most of the user manual you'll find a part written packet contents. Say packet contents. Say package contents. So in the package contents, for instance, what do you expect to find? Number one, or let's say that number one, you expect to find the measuring instrument name. What the name of the instrument? Measurement or measuring instrument name. Measuring instrument name. Say measuring instrument name. Say measuring instrument name. So if it is digital multimeter, then you'll find in this product overview, you'll actually find the particular name for that product. So even yourself, you have a name. Is it? Do you have a name? Yeah, so you can say that this is the user manual of 40 Naomi. This is the user manual of Juma. This is the user manual of Ramadan. Then the second package contents is called the test leads. Say test leads. Say test leads. Or sometimes we call them test probes. Say test probes. Then number three, you're expecting also in that box to find user manual. Say user manual. Say user manual. Also another package contents of the electronics measuring and testing instrument is sometimes something we call it calibration certificate. Say calibration certificate. Say calibration certificate. If what? If applicable. So calibration certificate. Say calibration certificate. So this is the certificate which will give you the permission to do calibration, but it's not compulsory. Okay. Then the next part, the fifth part, you'll find the power supply cables or cable, power supply cable, and the power supply cable, or you'll also find in that package batteries, either one battery or more than one battery. Listen. So when you say power supply cable, we means that, listen. Some of the electronics measuring and testing instrument, they just need a C to operate. Okay? So when you say that this is power supply cable, it's not like your computer adapter, but it's a cable. It's just a wire to transfer electric power from the socket into the instrument. So within the instrument, that depends where you can find what the power supply. But some of the measuring electronics and telecommunication measuring and testing instrument, they are just using batteries. For instance, this one, it just uses what? Batteries. Say batteries. Say batteries. Yes. So you'll find the battery if it uses battery. But for instance, signal generator, it needs a power supply cable. And then it means that the source of actual that the connection for the power. But also the oscilloscope, it needs also what? The power supply cable. Say power supply cable. Who have a computer adapter, a laptop adapter, so I can show you the difference between power supply and the power supply cable? Who has it? Please give me, because you might confuse as electric engineer. Then another components or package content is called the carrying case. Carrying case, if applicable. So this is the case that sometimes you can use to carry, applicable. For instance, for the digital oscilloscope that you have in our departments, they have carrying case. Okay? Okay, class. This is not a power cable. It is not a power supply cable, right? Listen, stop and look. This is not a power supply cable, right? This is, we call it a computer adapter. Say computer adapter. Say computer adapter. Why do we call it a computer adapter? Simple. The response is simple. Because the input of this computer adapter is what? AC. But this part, or this black box or black case, it contains the switched mode power supply to convert AC into DC. So the output of this computer adapter, it will be DC. For the most of the laptops, it ranges from 17 volt up to 19 volt. Are we together? So this is not a power cable. This is a computer adapter. It is standalone power supply, right? But when we talk about the cables, we mean that this is the cable. So this is what we call a power supply. Power supply it's just to transfer AC from the socket or from one point to another point. Are we together? Are we together? Okay. Did you understand? Did you understand or you haven't understood? Class, I'm talking to you. Today, what's going on? Ask your neighbor, why are you not talking? Ask again your neighbor, why are you not answering your teacher's question? Class, is it clear? Yes. Good. Then, this is the first part of 40 packaging contents, which is actual, will give you a brief overview. So, okay, what are the names of this instrument? In case you want to know, what are the names of this instrument? You just go the product overview part, you will see just the name, right? And then say, what I have, so what I've been given. Does this instrument need to use test leads or test probes? We just go to the product overview. And does this instrument actually has a user manual? Yes, it is there. And does it use what? Power supply cable or batteries? So you have just to check, to cross-check the product overview, then we'll get the answer of those questions. Are we together? Are we together? Are we together? Yes. Then we say that the product overview can also give you key components. Say key components. Say key components. So key components of that measuring or electronics measuring instrument. So what are the key components? What are the common key components in most of electronics instruments? The first key component is called the display. Say display. Say display. Say display. Display or display. So display screen, actually what the function of the display screens, we say that this one, it shows the measurement, so it shows the settings and what measurements of what of electrical parameters or electrical physical quantities. Electrical quantities. So this is the very important part. Does the instrument has display screen or it doesn't have? For instance, in our lab, we have also analog oscilloscope. Say analog oscilloscope. Again, say analog oscilloscope. So the analog oscilloscope, it has a display screen, but also we have analog signal generator. The analog signal generator, it doesn't have a display screen. Doesn't have a display what? It doesn't have a display what? So the main function of the display is actually to show what? Settings. Say settings. Means when we'll be setting the instrument. And what? Measurements of electrical quantities. So can you take your phone and download the image which has been shared by your CR about that digital multimeter? Can you take your mobile phone? Juma, have you already shared it? Huh? Yes. So please have the photo, the three-dimensional photo of this digital multimeter, because it will actually reinforce your understanding. So for instance, in this digital multimeter, this is the display screen. Say display screen. Say display screen. Actually, I think your eyes are the one that focusing on your mobile phone, not your mouth. Say display screen. Okay, so I think you have it. So for instance, now, the display does not display any information. Hello? Don't read your WhatsApp message, please. Be faithful. Don't check your TikTok comments. Just see, download the digital multimeter. That's all. Okay, so check. Look here. In this digital display right now, there is no any setting. There is no any measurements which have been displayed. So if I turn it on into AC or into DC voltmeter, right now you could see some numbers, right? So actually within this display there are settings. And what it shows settings and the electric parameter. So for instance, the setting that will be shown once I rotate it once, it shows DC. So it means that this is DC voltmeter. It shows DC volt. So it means that this DC voltmeter. You set the digital multimeter to operate as a DC voltmeter, right? But also it displays 0.0000 volt. What the meanings of this one? This there are, we say that electric quantity. It means that they measure the voltage when there is no any circuit which has been measured. It's 0.000 volt. Class, are we together? Are we together? Yeah, so that's a simple example. So Juma, I think also you have to take a photo when the digital multimeter is set into different measuring instrument. So that's the first part, the first key components that called the display screen. Again, say display screen. Again, say display screen. So ask your neighbor, where is your display? Show me your display, your own display. Because you're a product, you are measuring instrument also. Control button. This is the second key component. Control buttons or control knobs. Say control buttons or control knobs. Ladies yourself, I don't hear the voice of ladies in this class. And there are so many ladies who are saying that we wish to be a serious electrical engineers. Ladies yourself, say control button or control knob. You hear? Okay, gentlemen, because we are going to take power of our country. Say control knob and or control button. Say it. At least. But ladies now, the last chance. Say control buttons or control knob. Okay. So control buttons or control knobs simply say that this part describe main buttons. Describe main buttons. Example power button. Power button. Say power button. But also in this part you'll see function. We call them function buttons. Say function buttons. Say function buttons. But also in this part you'll see the key components that called either the measuring instrument has a range selector. Say range selector. Say range selector. What's going on with ladies in this class today? Class say control buttons. Again say control knobs. Okay. Then, so this is the second part. Class A, control buttons. Say control knobs. So when you say control buttons, actual, this part, describe to you about the main buttons. Say main buttons. Example, power button. So the power button, this is the button you are going to use to turn the measuring or the testing instrument on. Please put away your mobile phone. Control buttons or power buttons, this is the button we are using to turn on the electronics measuring and testing what instrument. Okay? Then we have another one, say function buttons. Say function buttons. For instance, for this digital multimeter, it does not have the power button. So the rotary switch on the range, hello madam, hello madam, hello madam, madam, come here. Yesterday you sat here, come here, come, quickly. Stand up, give that madam the position. Hurry up, come. That's why she's making stories. Okay, so don't concentrate about that madam who is moving. Ignore about that. This digital multimeter does not have a power button. Say power button. There's a difference between button and switch. Say button and switch. So actually the buttons you have to press. And the switch you have maybe to make it on or off. So the manufacturer has integrated the power button and the function and the range selector in this digital multimeter actually to be used as the one. So this point has been written off. You see off? So it means that the instrument is off. If you want to turn it on, there's no way that you can turn it on unless you select the measuring instrument. Are you together? But some of them, for instance, the signal generator, the digital signal generator that we have in our lab, and also the digital oscilloscope that we have in our lab, they have power button. You have to press it. When we'll be discussing about the other parts, you have to press it to turn the instrument on. Stand up quickly. Then we have function buttons. Say function buttons. So simply, function button for this digital multimeter, it's this one which is called the rotary switch. Say rotary switch. This is the rotary switch. We have so many different types of switches in electric engineers. We have mechanical switches and electromechanical switches. And we have also, yes, we have electromechanical switches where actually that integration of mechanical and the electronics. So this is the rotary switch. So this is called the function buttons or range selector. But the common names you can call it just the rotary switch or the range selector. But when you say about range selector, some of them are, the range selector is this one, which has been written range. So you have to set the range. Maybe the DC voltmeter to measure voltage in volt or in millivolt or maybe in microvolt. Are you together? If maybe you are measuring resistance, maybe the ohmmeter has to measure resistance in terms of ohm or in terms of kilo ohm or in terms of mega ohm. That's the means of who? Range selector. Are we together? Yes. Yeah. So then, so we have the next part. The third part. The third part is called what? The third part is called the testy probes. Testy probes. Say testy probes. Say testy probes. So testy probes for connecting to the device under testing. So for connecting to the device, connecting to the device under what? Under test. Connecting the device under what? Under test. So again say testy probes. Say testy probes. So actually this is providing the connection, the external connection between the measuring instrument and the part or the system that you want to measure, the particular electric parameter. Okay? So when you say that testy probes are just like this one. Are we together? Yes. Okay. Then the fourth key component we say that power source. Power source. Power source. That is still product overview. So in power source, it means that the power source actually here, the manufacturer has to say that the particular measuring instrument either uses the instrument may use, some of the measuring instrument may use what? AC power or DC power. So whenever we talk about DC power for electronics measuring instrument, we means that may use a single battery or more than one battery. Are we together? Then the first key component is called the ports. Say ports. Say ports. So ports for input connection. For input connection. For input connection. Example of common ports in electrical or electronics measuring instrument are called the temperature sensor. Sometimes you can be given a port where that you may connect a temperature sensor. Sometimes you may be given a port where that you can connect a flash or external hard drive. So that's what we call the USB interface. Interface. So listen, let me talk about ports. Say ports. Ports. Say ports. Ports. Say ports. Ports. In this digital multimeter, we don't have ports. Listen, stop writing. We don't have 40. We don't have 40. But in our digital oscilloscope, we have port. And that port, it's USB interface. Say USB interface. So those ports actual, they may act as the input to the measuring instrument, or they may act as the output. For instance, the USB, sometimes you may be introducing maybe the particular signal into the computer, into the measuring instrument from another source. But for instance, in case of our digital oscilloscope, this USB interface is actually used to capture the waveform. So you can capture the waveform and save into the maybe the external hard drive or the USB or the memory card. Then we can take that image or that capture and visualize it in your computer. You may even include it in your assignment or maybe in your report. I will show you when we will discuss about digital multimeter, digital oscilloscope. Are we together? Yes. Are we together? Yes. So that's all about product overview. I would like to hear some questions about product overview from you. Ask your neighbor, do you have a question about the product overview? Ask your neighbor, do you have a question about product overview? So give me the feedback. Does your neighbor has a question? If your neighbor does not have a question, then now you have permission to ask him or her to share with you the product part of his or her user manual. So do you have any question? Let me know. Do you have any question about product overview? Do you have any question? In this class, we are practicing, we are practicing digital electronics. In digital electronics, we just have two binary numbers, 1 or 0. So if I ask you a question, did you understand? I expect you 2 answers. Either yes or no, not silence. Did you understand? Yes. Do you have any question about product overview? No. No, ladies and gentlemen, let us dive into the first part of the user manual. What the names of the first part? Pardon? What the means of getting started? It means that how you can start to use the electronics measuring and testing instrument. How can you start to use your neighbor as a finished product designed from heaven, sent to the earth, and particularly East Africa, in the beautiful country that called Tanzania. Wonderful. Whether from Lake region or Lake zone or from central of Tanzania or western of Tanzania. How many people come from Kigoma or Katavi? Raise up your hand from Kigoma. Yes, wonderful. From Ruvuma? From Ruvuma? Yes, from Lindi? So almost we have people representing different regions of Oti. Okay, from Unguja? From Unguja? Unguja? We don't have Unguja. From Pemba? They didn't come, eh? Madam, are you from Unguja? Not from Pemba. Are you from Pemba? Unguja? Yeah, Unguja. I say, mimi mwalimu sijamfahamu vizuri huyo. Mwalimu anasomesha vibaya kweli. That is, we call it language in Unguja and Pemba. Say, getting started. Getting started. Then what do we expect it to learn from this part? So this section provides brief description about church, about how to begin, how can you start to use your measuring instrument. You are measuring what? You are electronics measuring what? Instrument. So in most user manual, you'll find this sentence. They are using this sentence to introduce the concept. To begin using what? To begin using what? Measuring instrument. Measuring instrument name. Measuring instrument name. Follow this initial setup state. Follow this initial setup state. So this is just the quoting from the user manual. That one is actual the functions of the getting started section. Class A, getting started. So actual stop writing. So this section provides brief description. Say brief description. About what? How can you start? Not how can you be professional. How can you start to use what? You are measuring what? Instrument. And in most user manual, actually they used to introduce this concept in this way. To begin using, then you are measuring instrument name. What does it mean? For instance, if the user manual for this digital multimeter, then we find that to begin using this digital unity, which is called Unity T, OUT61E, Unity T digital multimeter, follow this initial setup steps. Are we together? Yes. Yeah. So if that's the case, then the following setup steps, we have almost 4 setup steps. The first one, so this we call it 4.1. The first setup state, it means you'll be asked to unbox what? The instrument. Please put your mobile phone away from you, concentrate to the class. After the class, you'll keep on chatting. Say unboxing the instrument. So the electronics measuring and testing instrument are always packed into the box. Ask your neighbor, do you have a box of your mobile phone? Or you have a box of your SIM card? So, unboxing the instrument. So how can you unbox the instrument? This is how. Ensure all parts listed in the 30 are listed in package contents. Package contents in the steady main part, in the steady main part of the user manual, So of the user manual are included. Are what included? That the first C are getting started the information. Say unbox the instrument. Say unbox the instrument. So when it means for operating, when you be unboxing the instrument, maybe unboxing the digital multimeter, or unboxing the signal generator, or unboxing the digital oscilloscope, then you have to ensure, say ensure. You have to ensure what? All parts listed where? Listed in package contents in the 30 main part. Right? Package contents in the 30 main part of the user manual are what? In case something is missing, you have to communicate the manufacturer or the dealer or the supplier. Are you together? So, so tell me, what are the components? What are the parts listed in package contents? The first one, test leads or probes, right? The second one, user manual. The third one, calibration certificate if applicable. The fourth one, power supply or batteries. The fifth one, carrying case if 40. So you have to ensure that. Then after that, on getting started, once you are sure that all of the package contents are there, then now the manufacturer will teach you how to power on the instrument. How to power on the instrument. Say power on the instrument. Say power on the instrument. Say power on the instrument. How do we power on the electronics measuring and testing instrument? Well, this is what you expect it to get from what? So this is number 4.2. Power. No, this is, yes, for this case, this is number 1, sorry. And this is number 2. Then we say that the following are the steps that you have to follow in order to power your instrument. If the instrument is powered by the C or batteries, like the digital multimeter which I've demonstrated to you. So then we say that, then insert what? Insert the button. And remember that this digital multimeter and all the digital multimeters actually use the 9-volt battery. Say 9-volt battery. Yeah, so the 9-volt battery. The 9-voltage battery. Okay, after you insert the 9-volt battery into the compartments, into the compartments as indicated. As what? Indicated. Indicated where? In the 30 part. Stop writing. In case of the power on the measuring instrument, we expect it to find either one between the two pieces of information. If that measuring instrument uses the C, then you have to insert the battery, right? Maybe that measuring instrument needs a C power supply or it needs a C power. Then we'll hear what the manufacturer used to tell us. Are we together? Are we together? Yes. So if the instrument uses a C, there's no battery to insert. So that's what we say. If the instrument is powered by batteries, then insert the 9-volt battery into the compartments as indicated. Then 2.2, we say that if the electronics measuring instrument electronics measuring instrument is powered by AC power. AC power. Then connect the power supply cable into the socket, the wall socket, or into the AC main source, and the measuring instrument. What does it mean? Can I have your adapter to demonstrate? So suppose that, so where the power cable? Suppose that the measuring instrument uses AC power. Stop writing. So how can you power? Hello? How are you? Are you fine? Do you own one of the monocasi? Do you own one of the monocasi? No. Yeah, your neighbor, it's not you. Who is actual? Okay, so this is your power cable. Suppose that this is the power cable. You have to connect this power cable into the AC main. Say AC mains. So the AC mains, it may be the wall socket, or the power from extension, or the power from any AC source. Okay? Then you have to connect the second part into your measuring instrument. Are you together? Means you have to plug. For instance, that if this is the power supply cable, then you'll find in that measuring instrument whether in this position you have the place to plug, or in this position, or in this position, or in this position. Are we together? Yes. Then from there, you have already connected your power, or you have already connected your measuring instrument into the power source. Okay? Okay, class? We are still in the first step, getting started. So ask your neighbor, how are you connected? How can I power you on? Ask your neighbor, how can I power you on? I said ask your neighbor. Even if your neighbor doesn't talk, your neighbor is slumbering or is unhappy, just ask your neighbor, how can I power you on? Talk to your neighbor, please. Like it charge? Like it charge? Unlike it charge? That is all about electrostatic or static electricity. Then the next part is connecting the testing leads. So the manufacturer will teach you how, because you didn't turn on, listen, for this step, we did not turn on the instrument. We just connected the instrument into the power source. In operating instruction, that the point where when the manufacturer will teach you, or will teach us how to power on, or how to start to use, or how to maybe to press the buttons, the on-off buttons in order to turn it on. Are we together? So for this process, we just connected it into the power source. For instance, right now, there's a battery, but the digital multimeter is off. So that's what we are talking in this state. Okay? The manufacturer did not yet teach you how to power on the instrument. Are we together? Wow. So say connect the test leads. Say connect the test leads. Say connect the test leads. So the manufacturer actually will teach you in this style so you'll find the sentence for what? For voltage, let's say for the digital multimeter, we take as just a simple example for voltage or current in milliampere. Measurement. for voltage or current in milliampere measurement. Okay, measurement. Connect. Okay, so for voltage or current in milliampere measurement by, let's say, using digital multimeter. Just as an example. This is just an example. Okay, for digital, by using digital multimeter, then we say that, how do we connect the test leads? Say test leads. Say test leads. That is not test 1 and test 2, eh? Because when you mention test, some students remember about test 1 and test 2. So connect the ready test lead into voltmeter or ohmmeter, to the voltmeter or ohmmeter, milliampere, capacitance, frequency, terminal. And connect the black test lead or the black test leads into the COM, into the COM terminal, yeah, COM terminal. So this is one of the example of how to connect the test leads. When you talk about test leads, just to remind you, we mean about this one, right? Yes. So how the sentence is operating, this is for how you can connect the test leads. Number 1, for voltage or current in milliampere, say milliampere, measured by using digital multimeter. We say that connected the ready test leads into into the terminal, written that voltmeter, say voltmeter, ohmmeter, say ohmmeter, milliammeter, capacitance meter, frequency meter, terminal. So this is the terminal that called this name. And connected the black, uppercase, and connected the black test lead into the COM terminal. Say COM terminal. COM is an abbreviation of common. Say common. Say common. Okay, now take your digital multimeter. Take the image of your digital multimeter. If you don't have, maybe you don't have the band or whatever, just share with your neighbor. Check it from your neighbors. Take your digital multimeter. Have you seen it? These are the one that we call them terminals. Say terminals. Say terminals. How many terminals do you have in this digital multimeter? 4 terminals. The first one, the second one, the third one, the fourth one. Okay? So then you have to take a ready test lead. Then the instruction from the manufacturer. Connect the ready test leads where the point which has been written there is a capacitance symbol, say symbol of capacitor. Then there's a symbol for voltmeter, right? Do you see it? Or ohmmeter, do you see it? And here it says into 40 frequency. It means that that's the frequency meter. So now let me connect it, the test lead. Right? Next, I have to connect the black test lead. Where? In the COM port. So where the port which has been written COM, this one. So you just connect it here. You are done. You see how simple it is? So ask your neighbor, how can I connect the test leads to your user manual? How can I connect the test leads to you? Because you are the measuring instrument. How can I connect the test leads into you? Class, are we together? Are we together? What the meaning of this one? Say voltmeter. We'll discuss about this one in 2nd chapter and 3rd chapter. Very interesting. I would like to ask you that don't miss it. because you'll enjoy about voltmeter. I think that you have learned in O level and A level, but we are going to learn in different way, and especially with perspective of who? Engineering. So say voltmeter. Say ohmmeter. Say milliammeter with joy. Say milliammeter. Say capacitance meter. Say frequency meter. Frequency meter. Okay, so that is for voltage or current in milliampere watt measurement. This is the key information. So when you talk about voltage, this is voltmeter, right? When you talk about current, this is milliammeter. Are we together? Yes. But in addition, in case for the resistance, we are going to discuss about resistance measurement and also some other issues. 3.2. For the current measurement, lies between 1 ampere and between 1 ampere and 10 ampere. 10 what? Connect the ready test lead. Connect the ready test lead to voltmeter terminal. Not to voltmeter terminal, no. For this one it means for this digital multimeter, we call it in 4 to 10 ampere terminal. 10 ampere terminal. And what? And they connect the black test lead. Connect the black test lead. Connect the black test lead. The black test lead in what? To the COM terminal. This is example of getting started. Connect the test leads, especially for the digital multimeter. COM what? Terminal. Stop writing. Stop writing. Listen. In most digital multimeter, whether manual or automatic digital multimeters, we have 2 terminals for the current measurement. Say 2 terminals for the current measurement. Say 2 terminals for the current measurement. Remember your physics of Form 2 or Form 2 physics. How do we connect an ammeter into the circuit? An ammeter should always be connected in series, right? While voltmeter should always be connected across or in parallel to the 2 points where you want to measure the potential difference. Hello, I said, listen, look, and just see, attract your attention to me. Just see, watch me. Tell your neighbor, watch. So, because an ammeter is always connected in series, so an ammeter should always have current protection. For that case, we use to protect the electronics measuring and testing instrument by using fuse, especially if you are using, or if you want to do the current measurement by using a milliammeter or an ammeter. Right? Right? So we are using what? Fuse. Say fuse. Say fuse. Fuse. You know fuse? So fuse is a what? Is a safety protection element against the overcurrent. Okay? So we have 2 terminals, 4 terminals as we discussed. We have 1 terminal which is it has been written 10 ampere for the multimeter that you have. It has been written 10 ampere max. Then we have another terminal which it has been written common. Common? No, milliammeter. Yes, for this one. So, milliammeter and what? Microammeter. Yes, milliammeter microammeter. Let me just use drawing to explain this concept. And then you have another terminal, we call it COM. Say COM. Say COM. You have another terminal which you call T. We call it. I'm not teaching you about digital multimeter, but just I want you to understand and not to claim. This is capacitance meter. I have voltmeter. Then there's your ohm meter. There's a frequency meter. So how many terminals do you have? How many terminals do you have? In some of the digital multimeter, this terminal is combined with this terminal to make one. So what the difference here? This is an ammeter and this is a microammeter and the milliammeter. Say microammeter, milliammeter, and ammeter. Again, say microammeter, milliammeter, and So, what the difference? Why this has been isolated? Well, the reason is in practical electrical engineering, especially for the small current, we have fuses which their maximum threshold current is 1 ampere. And then this one, there is a fuse to protect the ammeter, which is maximum current is 10 ampere. Okay? So if you are doing the measurements of current less than 1 ampere, you have to place the ready test leads on this the ready test leads on this on this terminal. If you are measuring the current for the currents greater than 1 ampere, then you have to connect the ready test leads here. Are we together? If you connect it, then you are going to destroy the milliammeter. Because for instance, if you are measuring 2 ampere, and then you connect the ready test leads, it means 2 ampere is greater than 1 ampere. So the fuse will blow out. Class, are we together? Yes. I'm teaching electrical engineering students. If I could be you, I could be happy because now we are talking about all about what? Electrical engineering. Engineering is all about what? Engineering is all about what? Drawing. Engineering is all about what? Calculation. No. Engineering is all about what? Measurement. No. Engineering is all about what? Table of results. Good. Engineering is all about what? Formula in the equation. Engineering is all about what? Drawings. Engineering is all about what? Graphs. That's all. So, but the first one, engineering is all about what? Numbers. Say numbers. So these are the numbers. Very interesting. Numbers is unit. Are we together? Yes. Are we together? Class, are we together? Yes. Yeah, so that's how we do. That's what the manufacturer was actually presenting to you. So the difference is the fuse. And then listen, if for instance you are measuring a current less than 1 milliammeter, or just less than 1 ampere, and then you say, let me connect the test leads here. The digital, that the ammeter will not measure that amount of current because it's outside of its range. So in this terminal, this ammeter will measure current from or between 1 ampere to 10 ampere. While this one will measure current less than 1 ampere. Are we together? Yes. Are we together, class? Yes. Okay. Then the first important part for this getting started is now how can you turn on the instrument? How can you turn on the instrument? So that's number 4. So number 4, we say that how can you turn on the instrument? So turn on what? The instrument. The measuring instrument or the testing instrument. How can you turn on the instrument. So we say that press. So press what? Press the power. Press the power button. Press the power button, or rotate, just like in our digital multimeter, rotate the rotary switch. Rotate the rotary switch. Rotate the rotary switch to particular measuring instrument. Particular measuring instrument, and wait for the display. Display to initialize. Turn on the instrument. How can it turn on the measuring or the electronics measuring instrument? So these are the instructions. Press the power button. Say power button. Power button has been mentioned where? In the key components of what? Getting started. If that measuring instrument, it has a power button. Or you've been asked to rotate the rotary switch. Say rotary switch. Yes. In particular what? Measuring instrument. And then you have to wait for the display to initialize. Where did you introduce the display screen? In the key components of getting started. Class, are we together? Yes. Yeah, so listen. So when you talk about, for instance, the digital multimeter that we have, it doesn't have the on portion. So once you rotate this rotary switch once, then you have set the digital multimeter into the particular measuring instrument. It's on, but also you have set it into the particular measuring instrument. For instance, if rotate it once, you have set it into digital, into DC voltmeter and the AC voltmeter. When you rotate for the second time, it is still on, but you have set it into DC millivoltmeter and AC millivoltmeter. Hello, I'm demonstrating. Hello. Then if I rotate it steady time, I have set this digital multimeter into three measuring instruments. The first one, it's continuity tester. Say continuity tester. Say continuity tester. Say continuity tester. The second one is ohumeter. Say ohumeter. The third one is what? Diode tester. So in this part, we have testing instrument and measuring instrument. Later on, so I will teach you about it. I'll give you examples of measuring instrument and the testing instrument. Are you together? Yes. Yeah. So if you rotate second time, we have capacitance meter. Say capacitance meter. The digital multimeter, it's on, but also we set a specific measuring instrument. If you rotate it again, you have frequency meter. Say frequency meter. My brother, you don't have mobile phone, and then you are not watching what I'm demonstrating. Then if rotating again, you have the AC milliammeter. And what is AC microammeter and DC microammeter. Then once rotated again, you have what? Hello. You have the photo, the image, but you'll be reading the WhatsApp message. So say, so you have DC milliammeter and DC and what? And AC milliammeter. Once you rotate to the last portion, we have what? DC ammeter and the AC what? That's all. The digital multimeter, it is on, but you've set a specific what? A particular measuring what? Measuring or testing what? Instrument. So here you have to say testing what? Testing instrument. Class, are we together? Yes. That is all about the first part of getting what? Started. If you have a question about it, ask. Is it clear? Yes. Is it clear? Yes. Class, is it clear? Yes. So, let us discuss the first part and then we end the class. It's not longer, it's short. What are the names of the first part? What are the names of the first part? Operating what? Yes, I have to teach you because there's a close relationship between operating instruction and what I've taught you in getting started. Right? Then the next lecture will start step number 60 up to the last one. Because warranted support is just 3 sentences. So some of the parts are longer, some of the parts are shorter. Okay? Okay? Yeah, so ladies and gentlemen, let me introduce you the first part that's called the operating what? Instruction. Say operating instruction. Say operating instruction. Say operating instruction. Again. Again. Are you sure? This section of user man, I will end this lecture within a short time. Because God is telling me, Olenjolai, your students are saturated. They are about to be saturated. I had a plan to teach you 4 parts. But then the plans has been changed in this class. Because God is at work. And God is the one who is teaching you, not Olenjolai. God in Olenjolai is teaching you. Tell your neighbor, God in Olenjolai is teaching you. Are you sure? How are you sure? Prove it. Somehow. Others? No idea. Others? You just challenge. Can God stay in human body? Huh? Okay. So can operate the instrument safely. The instrument is safely to measure different physical quantities. Physical quantities. So this is the simple description of operating instruction. Say again, operating instruction. Ask your neighbor, do you like to operate or you don't like to operate? Haha! Show a smile when you ask your neighbor, my neighbor, do you like to operate or you don't like to operate? Ask your neighbor, please. 10 years ahead, we'll have wonderful bosses in this country. Wonderful leaders from this class. Okay? Wonderful electrical businessmen and businesswomen in this class. 10 years ahead. So don't lower the credit of your neighbor. He or she might be your boss. Okay, just wait. Because you think that the leaders of our countries, they have studied in different institutions. No, they have studied in this institution. So operating 1, 2, 3, reinforce understanding, because now your memory card is kind of full. Read the sentence. Quantities. You began with a high frequency, then you lower the frequency. Again, 1, 2, 3, let us read. Yeah. So some of you are just measuring quantity. Okay, well, I think that you have understood. So this section of the user manual I think I repeated it twice. Yeah. You are allowed to correct me. I am a human being. In Tanzania, I know that most teachers, they don't accept to be corrected from students. But for myself, one of my uniqueness, you can correct me. Right? You can what? And live correction, not confidential correction. Live what? On the spot. Should not say that, oh, sir, there, you used the user manual twice. Those who have been copying, they have just copied, okay? So don't, please don't inspect your neighbor's exercise book. Just leave it. Because your neighbor say, I will delete later on. Okay, so this section of the user manual for electronics measuring instrument describes on how the user can operate. Say the user. Say the user. So your neighbor's user, right? Your neighbor's what? Can operate the instrument safely. So ask you, your neighbor, can I operate you safely? To measure different physical quantities. Then let us just have just a few examples. So 5.1. Stay connected. Just within a short time, I'm going to finish the class. So number 1, we say measuring voltage. Measuring. How do we use, let's say, a digital multimeter to measure voltage? Say measuring voltage. How do we use it? Mean that in this part you'll get a question. How can I use this digital multimeter to measure voltage? You'll get the response in this part. Okay? While the test leads are already connected, the battery is already connected. So in measuring voltage, you will be just see in most of the data user manual of digital multimeter, you will have only 3 steps to follow. Simple. 3 steps. The first step is this one. Number 1, you'll be asked that set the mode of digital multimeter. Okay, set the modes of the digital multimeter to DC. Who is making noise? Your neighbor? So VDC. Using the range selector. The range selector. Or we call it rotary switch. Or mode button. So if you want to use this digital multimeter to measure voltage, then you are supposed to do what, class? Set what? The mode of what? To what? DC what? In some of the digital multimeter you'll find that VDC. VDC means that DC voltage. Say DC voltage. Say DC voltage. By using what? By using what? By using what? By using what? Or what? Or what? So this is the rotary what? Switch or range selector. Listen. Listen. Listen now. Let me add something in your mind. This is the rotary switch. Say rotary switch. For instance, if I want to set into DC voltmeter, right? But maybe the range is not the one that I want. I have to press also the button written range. And then I will change. So I will have another range, I will have another range, I will have another range. Means you can set a range to have 1 decimal place, or 2 decimal place, or 3 decimal place, or 4 decimal place. Do you remember about significant figure? Your age has how many significant figures? Ask your neighbor, your age has how many significant figures? The second set of instruction, connect the probe. Connect the probes. When you say probes, it means ready and what? Black what? A to the what? To the circuit. Remember that in previous steps, in previous steps, we have already connected the probes. Sorry, there's no hello. The probes, say probes. In previous state, I've already taught you how we connect the probes into the measuring instrument. Okay? So now we have to take the probes and connect it to the circuit. Let me write and then I'll show you and you'll understand. To the circuit, under what? Under test. To the circuit, under what? Under test. Ready to the positive side. Connect what? Connect the ready probe to the positive what? The positive side of the circuit, and the negative and the black to the negative side of 40 of the circuit. What does it mean? Example. What does it mean? Suppose that you have a circuit like this one. This is not written in the user manual. This is just stop writing. Stop writing, look on the blackboard. This circuit is not written in the user manual. I just wanted to use it just to teach you how you do this process. Okay? So this is a light emitting diode. So actually it will be emitting some light. And this is the resistance, called the current limiting resistance. We are using commonly between 150 to 330 ohm. And then at this point, we have a battery, because it is DC, positive terminal and negative terminal. So positive terminal, but also we must have a switch to close and open. Listen please. Suppose that you wanted to measure the voltage across, the DC voltage across the light emitting diode. Say light emitting diode. Say light emitting diode. Say light emitting diode. So if you want to measure the potential drop across light emitting diode, remember that this part is called the anode. Say anode. Say anode. Anode means what? Anode means what? Positive, right? In case of electrolysis, anode means what? In case of electrolysis. Positive pole. And the cathode is what? Negative pole. Then what will happen if that cathode and anode dipped into the electrolyte solution? The chemical reaction will be what? Established. And the electrolyte will be decomposed into what? Ions. So physics, you are not there. Engineering, you are not there. Mathematics, you are not there. Even chemistry. Okay, good. Stay, enjoy your life. So actually, we used to write this way. If you want just to draw, this is the DC voltmeter connected, right? Juma. So this is, so actual, we'll be connecting the ready probe to the positive side. This is the positive side of this circuit. This is the positive side. This is the positive. I say look on the blackboard. This is the positive side of this circuit. And this is the negative side of this circuit. Okay? So connected the ready probe to the positive side of the circuit, because the circuit is DC. So this is ready. So this is ready ready probe. And then connect the black probe. Black probe to what? The negative what? Side. Then you'll have the steady state. So the steady state, read the voltage. So read the measured voltage. Read the measured voltage displayed on the screen. So the display will display the amounts of voltage flowing through this OT, light emitting OT diode. So you have to read it on the OT. You have to read OT. The measured DC voltage. Where are you going to read it? on the display of your digital voltimeter. Are we together? Are we together, class? Then let me just give you a simple challenge. What will happen if I swap, I interchange these probes? Hello, I said stop writing, stop writing, stop writing, stop writing, stop writing. Then ask your neighbor, because your brain now is tired. You cannot ask yourself. So ask your neighbor, what will happen if I interchange between the red probe and the black probe? If it means that at the anode I connect the black probe. At the cathode I connect the red probe. So ask your neighbor, what will happen? What measurements are you going to obtain? I said ask your neighbor on my behalf. If you start 5 students, it means 3 are neighbors and 2 are neighbors. Because as I say, I'm alone, I'm number 5, I'm number 5, I'm the odd number. Quickly ask your neighbor what happened. I said ask your neighbor, I will not answer that question for you. Your neighbor will answer it for you. And practically you will do it. Talk to your neighbor, please. Discuss. What did your neighbor tell you? The digital or the DC voltimeter will display the same reading, the same magnitude, but with negative sign. Yeah, that's how. Clap your hand for your neighbor. Yeah, clap your hand for your neighbor, please. Mwenye wivu ajinyonge sana. Iyo. Mwenye wivu ajinyonge sana. Yes, your neighbor has jealous upon you. Why? Because he or she consider you as expert in copying, pasting, editing, send. But today you did not copy from him or her. You gave the response from your brain. Okay, so now it's the time for the homework. Say homework. Say homework. So the homework is simple. Listen, I won't write a lot of words. So actually, in case of the digital multimeter, we are just, it means in operating instruction, we have just 3 instructions. The first one, how you connect it there. The first one is this one, how you set the digital multimeter. The second one, how you connect the test leads into the circuit. And the third one, to read the measure the electrical physical quantity displayed on the screen or the display. Right? So go and write and find how, means that operating instruction. So, operating instruction for AC current measurement. AC current measurement. Just 3 steps. Then also, just see, write for us operating instructions for resistance measurement. Okay? Yes. Okay? Yes. Hello? Is it clear? Yes. Okay, so I would like to say that this is the end of lecture 4. Wow. Give it out. Others are still unhappy, right? From the beginning of the class, unhappy. In the middle of the class or in the middle of the lecture, unhappy. At the end of lecture, unhappy. That's how human beings are extremely, or we call them super complicated. He or she is not unhappy because of you. No. There's a different reasons. And some of them are imaginary. Say imaginary reasons. Okay, well, so let's say this is the end. So let me know. Did you understand lecture 4? Yes. So how many parts have we discussed in total? 5, right? How many remain? 5. So join me in lecture 5 when we are going to discuss about it, the other 5 main parts. Did you learn something new? Yes. Sure? Yeah, so are you becoming a practical electrical engineer? Yes. Well, so let's say that thank you very much. This is the end of our lecture 4. And I would like to just hear the writers or manufacturer's mind or introduction sentence to say thank you. Thank you for learning and understanding what I've been teaching. But let me appreciate my Almighty God, who actually is always teaching me different tricks, different teaching styles, and give me comfortability. So I thank God who have given me this chance to teach you, and I'm asking God to give me another chance and another chance to teach you, and even your children, and even your grandchildren, and grandchildren, and grandchildren. That is actual that I'm praying. So let us pray together to meet in lecture 5 and everybody to be actual active so that we have to move. So let's say that this is the end, and this is Olenjolai, who is still actual that who was teaching you. I have some electrical engineering students. We call them BNG23 EE1. So now is the time to congratulate them. 1, 2, 3. Do you see your neighbor? Mwenye wivu wajinyonge. 1, 2, 3. Ongereni. Imarani. Wow! Thank you very much. May God bless you. See you in lecture 5.
Hekima,